everyone. My name is Piers Ridyard. I am the CEO of RDX Works, and I'm joined by Dan Hughes, the founder. Today, we're going to be doing some more AMAs. We've got a bunch of AMAs that have come in. This one's going to be this particular one's going to be some highly technical ones. People have been diving deep into various parts of the Radix cryptography, Radix consensus, questions about sybil, all of this kind of stuff, which is great to see. So we're going to answer. We're going to be going through and answering a bunch of these. But before that, how was your holiday, Dan?
Not long enough. They never are. I don't take many holidays. When I do, they're always too short.
Yes, and when you do, you decide that it's the time. The time is best spent hanging out on Twitter.
Wow, I need a break from the family chaos now and then. Anybody who's got a 3-year-old will know that going on holiday with said 3-year-old is not a holiday, especially when they're currently being toilet trained as well. So he finds going to the toilet a game. So you go to the toilet 17,000 a day, and he doesn't do anything because he just thinks it's fun. Or he wants me to go to the toilet.
Or they just choose to go to the toilet where they're sitting because they're too interested in what they're doing.
In the middle of dinner. In a swanky restaurant.
Yep.
Yeah, that's a good one.
Fun times. Alrighty, so let's get started with question number 1 in the order that it has been written by Jacob in this document. So I apologize if this is out of the order. It was actually people ask questions, but we're going through this order. So the first question is by cryptocactus, and it's a twofer. So, number 1, what are your thoughts on using Radix way of sharding in the non-crypto space for regular centralized databases? Might the design of many shards with unique shard IDs provided by SHA-256 hash functions have use cases there?
I mean, like when you look at what centralized or traditional databases do in terms of their sharding, which is also called clustering as well. They do a lot of what we kind of do already. So the bit really that's unique to the way that we do things is we have this fixed address space, right? The 2 to the power 256. And then you have these shards, which are state shards, and they contain the life cycle of something, from it being created, something happening with it, to it being destroyed or consumed or used or whatever. And I don't think that would bring any benefit to these kind of database implementations, right? Because they're usually permissioned anyway. So everybody knows who everybody is and what everything's got. You don't have... your kind of cross-shard consensus is very different because you only have a small group of participants taking part in any reads or writes that need to happen. And then when you step up a level from that, our shard groups, as I've coined them, which probably isn't the best term, but the shard groups actually look like a shard in a database environment, right? So a shard in a database environment is just a collection of data, that conforms to some specific set of rules on how it's been chopped up. And our shard group is essentially the same. The only difference is that just our shard group corresponds to a set of state shards, which a particular set of validators are responsible for. And in your database, the shard there, it's a chunk of state data on the database that a particular replica is responsible for. And usually, in a data cluster database environment, you may have quite a low replication threshold for that shard, right? So you wouldn't have hundreds of replicas in the sense where we would have hundreds of replicas. You would maybe have 5 or 10, maybe, right? And then all of the other shards would have 5 or 10 because you don't need the redundancy. You don't need to think about the permissionless aspects of things where you might have suddenly a chunk of your replicas go offline for some reason, or they move around, or they have failures because they're using unreliable power somewhere, or the internet somewhere wherever those validators are is unreliable, or whatever, right? Or the hardware is coming towards end of life and hasn't been maintained very well. You're in control of all of those things in your permission database environment. So even though from a kind of high level it looks similar, I don't really think there would be any advantage, because our sharding model is tuned specifically for permissionless, whereas databases that use sharding, clustering, whatever, they generally operate in a permissioned environment, and the two things are very, very different in terms of the way that they're tuned for the application that they're the service they're providing, right, or the environment they're operating within. And you do find aspects of the state sharding in large scale databases, right? There are these unique hash identifiers that live in a particular cluster that is responsible for a particular piece of state. So it's very similar in a number of ways anyway. Nothing really too radically different. It's just that our model has been tuned specifically for large-scale permissionless, whereas traditional databases are generally tuned for large data, but small-scale kind of sets of replicas in a permissioned environment.
Right. And there's the whole aspect of how the execution environment and how sort of like sits on top of that as well, and how that takes advantage of how state replication is done across the network and how it's sharded. So like each level of optimization is kind of like built across the stack for us, whereas normally what you have with and please tell me if I'm talking out my arse here, because I might be, but it feels like most databases are created to kind of be general purpose, and this isn't really created to be. It's created specifically for our execution environment, which is, relatively general purpose, but it's general purpose in a very specific way for a public decentralized ledger.
Yeah, like the specific really is state transitions, right? And so state transitions, in the way that we need to do them, don't really make sense in a database environment, right? Because you've got control of it all, and you've got various layers of hardware, software stacks all the way up from that clustered database that handle various things, right? You've got caches, you've got proxies, you've got all this kind of stuff, load balancers and all those kind of things, which can take a lot of load off the core database, right? And if anyone's actually interested in this, I'll find the YouTube link, but there was a great YouTube video that said, why is it so hard for computers to count? Right? And it's talking about, you're on Twitter and you see like a tweet from Elon Musk, let's say, and the number of likes is like going up a bit and then coming down and then going up and going down again and coming up. And it's kind of, it's peaky and troughy. And it's like, why? Why is it so hard for it to just count the number of likes, right, or the number of retweets or whatever it is? And this article goes, this YouTube video goes into it by quite a lot, right? And it talks about the fundamentals of like database architectures and large scale system architectures and all the bits and pieces that are actually between you on the client and the actual backend database that actually records all the likes or whatever, right? But obviously, in a permission network, you can't really have all those intermediate bits and pieces that make the general experience very kind of sleek for the user, right? You can't say to your validators, right? Okay, so you need a node for this, then you need a load balancer, then you need like a big cache, and then you need to have this piece of hardware, and then you need to have that piece of hardware hooked into these bits. You can't manage that efficiently in a permissionless environment. So you have to have everything really in one place. So again, your execution and state transition model and the stuff that's getting written to ledger has to take into account the fact that you can't realistically have all those different layers and intermediate kind of hardware and software services that you find in these huge scale database systems, right? It's not practical. So That's why, it's general purpose in terms of state transitions, but you want to do anything else on it, and it's difficult to do because it's been tuned for that particular environment, right? I want to track a piece of state reliably across this sharded network so that it's always true and it's always correct in terms of a client reading that back, right? Whereas in a traditional kind of large scale database system, you can do anything. You can stick anything you want on there because it is a lot more general purpose. And if you find a use case where you run into some issues, well, then you just add some intermediary stuff in the middle. You just go, oh, well, this is a bit slow or not performant or whatever. We'll just throw in this particular service here right in the middle, and that'll take the load off the back end. Can't do that.
Right. It's like, given the fact that a public ledger environment, you have to have consistency and resilience turned up to 11. Given that constraint, how do you build a high performance system is sort of where the sharding environment has come out, whereas you just don't have that in traditional.
Yeah, like if you can express something as a transition of state, which thankfully you can express many things with that, right? It's not particularly narrow. Then you can probably do all of the things that you really need to do in terms of a large-scale DeFi permissionless ledger, right? But then there's a bunch of things that you can't do that you'd be able to just do quite easily on a database system. And like one thing is doing joins and unions and stuff, right? Which you just can't do that because it doesn't lend itself very well to being able to do those kind of functions. Whereas on a database, even a clustered one, you can quite easily join huge amounts of data from different places and different tables because the model is different.
Let's move on to question 2 from the same person. How crucial is the near-uniqueness property of SHA-256 hash function for the Radix ledger? Is it necessary to make the combination of sharding plus consensus work, or is it there because it gives a good performance, i.e. parallelization? Would it be possible to use a simpler hash function that maps substrates into buckets, or would that break the whole design?
Near unique. I mean, for all intents and purposes, it is unique, right? I mean, you'd have to just count all the numbers that represent 2 to the power 256. You would burn through all the energy of the sun, and you still wouldn't get to the end. So let's just say that it's unique, right? It's important to a large degree because you obviously want uniqueness around particles and states and stuff, right? But there is also still obviously a chance for a collision, right? I mean, it could happen. Yeah, I could spin up a Bitcoin miner, and there's a probability that I could mine the next block forever on my little USB ant miner. It's a small probability, but as that famous meme, you're telling me there's a chance. Yes, there is a chance. So you do have to kind of consider that you may get a collision, right? And in some things at some point. They'll be very rare, but you may get them. So what happens? Well, let's say that there's a piece of state that collides with a state shard that already has some state in there that's either in the up state, down state, or something's happened to it, right? That's okay because the actual the content is different, and there would be properties of the data which you would be able to identify. And obviously, as well, there would be a difference in time interval between the two things, right? Getting a collision over an unbounding time period is one thing. Getting a collision within a time bound that causes you problems, i.e. 30 minutes, is quite different, right? You probably need a lot of suns to burn through to cause that in a short period of time. So you have a latency in between them that you can also figure out which is the one that you need or which is the one that's relevant, right? Now, in most cases, what you would probably find in these collisions is that the previous state has just been exhausted, right? So if it was some tokens, it's probably been spent in the 1,000 years between a collision. So that's in the down state. So I can completely ignore all the historical stuff that is in this state shard, and so this is fine to be in there because that's done. It's up, down, gone. No one can use it ever again. And in the worst case, where you've got two pieces of state that are in the up, and there are other ways to identify which one it is that you need. So like in the actual data, right? One might be spending XRD and one might be spending a different token, DAN tokens, right? It's like, well, I've got this one, but this input, this transaction is referencing DAN tokens. So it's not that one that I need. I need this one over here because that one's spending DAN tokens. So there are additional identifiers you can use.
And from the point of view of how whether or not it'd be simpler, it would be possible to use a simpler hash function, or whether or not that would break the design.
SHA-256 is quite efficient, right? I mean, you can, even on just a commodity CPU, or even a Raspberry Pi, can churn through approaching a million SHA-256 hashes a second. So you're going to have to be doing some serious transactional throughput to be maxing out your SHA-256 performance. Right. And before you even get to that, you will have maxed out your elliptic curve verification performance anyway. So
cool. So I'm going to move on to the next question. The next question from Frostbite, but the O is a 0, 5, and an 8. So there's a question from Frostbite about Sybil. There's sort of been an ongoing conversation in the community about Sybil protection in Xi'an, and specifically Sybil protection in Xi'an with the Cassandra formulation of consensus. So I just want to preface this again with the Cassandra is explicitly a research network, and this research is still ongoing. So like it's fine to have conversations about this, but a lot of it is sort of quite different from what the current consensus and current Sybil protection mechanism of Olympia network that's running now, and what will be the consensus and Sybil protection of Babylon. This is still very forward looking. So I think that
it's forward looking in the sense of the implementation, right? But ultimately, your fundamental is still the same. You have stake, and at a particular threshold of stake, you're able to do naughty things.
Yes.
And what I'm working on is how do you maximize the efficiency of using that stake in such a way in a sharded environment so that you can ensure that you're at least getting close to those upper bounds, if not meeting.
And so a lot of the questions are around this, like how does the probability interact with those upper bounds of being able to do naughty things, or lower bounds of being able to do naughty things in a sharded network with this sort of like manner of Sybil protection. So, instead of spending a lot of time on this AMA going through that, like Dan is writing a paper, and that paper is going to take a while to come out. Like we are still a long way from when this is looking to be applied to the public network. And so once that paper comes out and starts to actually look at these theoretical approaches to Sybil within a sharded environment, I think then it would probably be the best point to pick up these again. Because if I've learned anything from my interactions with you, Dan, the thing that's often most frustrating is getting the little snippets of the full model and then trying to like map those snippets, because you want to intellectually, it's something that you want to do, map those snippets.
It just gets a little bit like, it's a balance of letting smoke turn into fire when people ask questions, because if I don't respond at all, then people get anxious and potentially some FUD arises, and why isn't Dan answering these questions about Sybil? He doesn't have an idea for it, blah blah blah. The world's going to end. But then there's also the other side where when you make some statements around the broad characteristics of what it is I'm looking at, and there's gaps in the middle, then sometimes those statements are taken either explicitly or in the wrong context, and then someone goes away and crafts some kind of test that obviously blows a hole in it, right? Because it's not fully explained and it's not fully defined. And then there's a round of applause, and I have to then go in and stomp on that foot. So it's just it's difficult not to, and it's difficult to address it, because either way, I always end up having to spend hours in Telegram.
Right. Whereas the most efficient way of answering these questions ends up being eventually just writing the full sort of explanation of the model with enough detail for people to be able to
But in the meantime, everybody's having a meltdown because I'm not saying anything about it. So it's just difficult. I mean, like there's just two small statements I want to make about this, right? Number one is it's a trend, right? I've said this many times. What in a sharded environment, your sybil guarantee it will not be you need 33% or more of stake to control the network. It will never be that, right? It will always be a trend of you need some portion of stake against the current network configuration in order to have a probability of X, right? So if in some particular network configuration, you may only need, say, 10%, and if you're willing to wait a long time. And in a different network configuration, you might need 20%, and you still have to wait years. And so but it trends, right? You're never guaranteed that you're going to be able to cause a liveness break until you're at 30%, 33%. That's where you're guaranteed to do it. But you might be able to do it with slightly less if the network is currently in conditions that are favorable to you in some way. Now, that doesn't mean that if I have 33%, I can cause a sybil break every 20 minutes, because it's a probability, it's a trending probability, right? It might be that if I have 20% and I wait long enough, then I'll be able to do it. But the difference here is I've got to wait, right? If I want to accelerate my chance of being able to break the network, I have to trend up the amount of stake that I need, which is different to, say, an unsharded network where it's like, well, if I have 20%, I can wait forever and I won't be able to break anything. Right. So it's trending. And the statement that I've always made is that it's trending towards 33% if you want that guarantee of being able to break at any moment, like you can in an unsharded. Right. And then the other thing that seems to be getting misinterpreted is that if I make a million thousand XRD nodes, they'll all go in the same place. They don't go in the same place. There's still a random element to it. There's no explicit logic that says, if 1,000, put with these other 1,000. It doesn't work that way. So that's why when you have these huge amounts of small state validators, you're still not guaranteed to be able to make any liveness space, because ultimately what matters is the amount of state you control. No matter your quantity of validators has some effect on your probability, but ultimately the baseline is how much stake have you got across all your validators. And if that stake is a low percentage, then you'll be waiting a long time, no matter where your validators go.
And then sort of the other aspect of this is that people often talk about that the lower security bounds of a network in sort of like classical BFT being 33%, but to actually be able to do something like double spend, there are theoretical attacks where you need 33% to be able to do that, but you also need to be able to isolate nodes as well.
And convince them that
you're correct. When actually the bound that you tend towards having a real issue in a network for double spending is 66% under a normally functioning communication topology on top of a public network. And so, and like, again, it's tending towards 66%.
It trends towards the 66%, right? So if you have 50%, maybe you'll get lucky after you've waited for 300 days, right? But if you've got 60%, you'll get lucky after maybe 100 days. And if you've got 66%, you'll get lucky after a day. If you've got 67, you can do whatever you want.
Right. And so I think all of this will be much clearer when the paper comes out. But I would say to the community, don't stress too much about this. There's a long time to go before this becomes urgent, important for full definition, and like, understand that the more time that Dan spends in the community arguing about it, the less time it actually has to just write up all of the research that has come out of Cassandra. So they're great questions.
Yeah, I mean, like the last week I spent nearly an entire day building code to test and prove out these probabilities, right? I actually built simulators to do it, shared bits of the code and stuff, ran the probabilities and that. And if that's not enough to convince you, then you're just going to have to wait. And I've got, that sybil paper is second in priority to the Cassandra consensus paper, because we need to get that nailed down because it's nearly there. And we have all the Cassandra test network stuff and the RDX Labs website going up soon. We would like to have that content on there. So Cassandra papers first, and then Sybil is second.
So yeah, I mean, we will not. It's not that we don't love the questions. It's that we're trying to make sure that the right priority of things is being done at the right time. So we won't be addressing any more Sybil questions on these AMAs, and Dan will be reducing any further sort of interaction with that until such time as we have the papers out. But like, it's going to be a bit of time. But you guys are heard, and we're definitely going to make sure these are addressed at the right time. Next question is by Che.Stuart. I am ultimately wondering if Radix would allow individual clients, such as a smartphone, to interact with the blockchain as a node itself. But obviously, I don't understand enough to know how that affects staking. Nevertheless, if Radix's approach to POS, again, assuming I understand these terms well enough, balances of the ratio of client servers, I think I would be permanently sold. So, will smartphones be nodes?
I think I know why this question's come up, because somebody did an implementation of Cardano running on I think it was an Android, I think. So yeah, they had a Cardano full node basically on an Android. I think it was an Android device. And so phones have a lot of storage these days, right? And they have fairly punchy processors. And we've run tests with various things on low performance, low scale devices before, like the Raspberry Pi and stuff. Right now, your smartphone's arguably got a lot more compute and performance than a Raspberry Pi does. So from a technical point of view, like a pure technical point of view, can it do the hashing? Can it do the signatures, etc., etc.? Can it do the VLS stuff that we're going to need and all that kind of stuff? Then the answer is yeah, you could use your smartphone. The two issues is that one, storage, right? So potentially you're going to be looking at hundreds of gigabytes being used on your smartphone in terms of state, because we don't have any kind of real stateless stuff yet. And number two would be your connectivity, right? If you're acting as a validator and you're out of signal for a period of time, then you're going to get slashed. Or your battery goes dead because in the background it's processing lots of transactions and it goes flat on you when you're on the train to London or something, right? So it probably isn't ideal in terms of using your phone as a validator, but you could definitely use it as a replica, right? As a read and observe replica. So clients could connect to your phone over some API endpoint potentially, and relay transactions and information backwards and forwards across your phone as a full node that's just storing replica, right? And it could do checks and balances on consensus maybe as well. So does this loop correct, or am I detecting potentially a liveness break here or whatever? So maybe that kind of stuff. But definitely wouldn't recommend using your phone as a validator. It's just connectivity isn't reliable enough,
right?
And it'll just eat storage,
right?
So you could, but you probably shouldn't.
And his follow-up question is there something about Radix that makes it specifically oriented towards decentralized finance? If not, why market it as the ultimate decentralized finance solution? Why not just market it as the ultimate blockchain solution? It's an interesting question, and there's like some part of it's philosophical and part of it is to do with how we've like tweaked everything. There's a bunch of stuff that DeFi wants as a feature set, sort of like fast finality, the ability to have atomically composable application transactions where you're like borrowing from one application and swapping on another one and then repaying the loan and doing that all within a single operation and doing that across shard. And then there's a bunch of stuff in the Radix engine, like the fact that the Radix engine gives you a bunch of basic functionality like tokens exist within the Radix engine, and NFTs exist within the Radix engine. The concept of swaps exist within the Radix engine that makes the language incredibly elegant. So Scripto being an incredibly elegant language. Again, if you look at the architecture of the language of Scripto, it's very much focused towards this idea of financial applications, and the way in which it deals with the idea of tokens being a primary function of the ledger, where tokens are expected to be representing value. Now, they could be representing, real world assets, or they could be representing crypto assets or stable coins or whatever. But these being the primary functionality of the ledger, lend itself very well to a better, more elegant way of creating a programming language for that. So an asset-oriented programming language, because you are dealing with assets, and a Radix engine that is able to create an immense amount of functionality and security in how it executes that functionality for things like tokens and stuff like that. So that's sort of like how everything is very much focused on building for what is probably the biggest single addressable market in the world by value, which is the global financial system, $400 trillion market, which is the single biggest market in existence, full stop. From a philosophical point of view, when you create a company, there's focus is always a key factor, especially as a company grows. Being very clear about what its identity, what its target customer is really important, and that also covers, for example, in crypto, the community. Like, if you have a community that all want to do the same thing or similar things, then they are able to bounce ideas against each other, and there's a momentum to sort of the collective intelligence of the community around what they understand is being built for a platform, and that creates its own sense of momentum. Developers come here because they're interested in finance or decentralized finance, and entrepreneurs come here because they're interested in decentralized finance and Web3, and so you get this convolution of ideas and people that want to work together, and then that creates its own momentum in terms of what kind of applications are built on top of it. And then in DeFi, the interactivity between applications really matter. So if I have one application which focuses on lending and borrowing, and another application that focuses on exchanges, then you get this exponentially valuable network effect as a result of multiple applications that are focusing on the same sort of financial application type, that actually are more valuable as a result of their interactivity as well. And so all of this brings together the reasons that you focus in on a particular application. My favorite saying on the other side of that is, if anyone knows what Woolworths is in the UK, there was this shop called Woolworths, and it kind of sold everything. And someone once said to me, Woolworths failed because no one knew what you went there for.
You went there for picnics.
Right. But if you wanted to go and buy a paper, then W.H. Smith's was better. If you wanted to go and buy socks, then Marks and Spencer's was better. If you wanted to go and buy name anything, it was this shop that sort of sold everything but didn't do anything particularly well, and as a result it failed because it didn't actually know who its target customer was. And people think in categories, like very broad categories and then narrower categories, and being able to identify what the category of application and person and community and developer, and what you're actually tweaking the performance structure of the ledger for, means that you can create something that is incredibly good for a particular subcategory with an incredibly good support network around that. I don't know if you have anything to add to that, Dan.
There's only really one thing I want to add, actually, because I see this question come up quite a lot as well, and sometimes there's like a variation as such where I feel like people think that, let's say that DeFi went away, right, for whatever reason, or it became a smaller market compared to some other category, right? I feel like there's a bit of a misunderstanding around, well, if that happened, we'd have to throw away all the consensus as well and do the consensus again. Now, that's not true, thankfully, right? Or let's say that we've taken over all the DeFi, and it's like, okay, what we're going to go and disrupt next, right? We've got DeFi, we've got 400 trillion. What's next for us? So consensus fundamentally doesn't care what it is. Right? It doesn't care what the data is. It could be transactions. It could be cat memes. It doesn't care what it is. All it cares about is there's this thing that I need to get agreement on within this collective of actors, and that's all your consensus is really doing. Now, what's defining the conditions for agreement is your application layer, right? Your Radix engine, the constraints, right? Which is, Dan can't spend this because Dan doesn't have enough balance. The consensus doesn't care about that. The consensus is just, I've got this thing and I need to get agreement on it. And then what the conditions on how agreement, if it's viable for agreement or not, are set by something else. So the Radix engine and scripto and stuff then defines, no, this can't happen because there's not enough balance. But your consensus, the bit that drives all of this, right? The roads, as you like, doesn't care what kind of car you're driving, right? Roads don't care about what kind of car you're driving. It's a truck, it's a car, whatever it is. It's just roads going to places. Same with consensus. It doesn't care what you're moving across it. All it cares about is getting agreement on something. And sometimes you need an external element to provide the constraints, which is, in this case, the Radix engine. But the consensus, Cerberus, whatever, doesn't actually care fundamentally what it's moving. It's just bytes.
Yeah, and I think I should also say that what my definition of decentralized finance is, like my definition of decentralized finance is representations on assets on decentralized infrastructure with the programs that deal with those assets, either partly or wholly represented on the public ledger. That covers NFTs. I don't see the NFT space as not being part of DeFi. Like it absolutely is. Right now we're in the very simple phase of NFTs. Like for me, NFTs are like 2017 tokens were, where everyone was like, oh, you can tokenize everything. And it was a very simple application of tokenizing everything. It's like, oh, you can create any marketplace, and let's create a marketplace for lawyers, and let's create lawyer token. And then we can use tokens to, buy and sell legal services. And what we realized is that the concept of tokenized marketplaces is a really good one. And that's kind of what DeFi sort of is. DeFi is financial marketplaces for tokens, but it's a subset that is like a fractal, right? Like you go, oh, token applications, tokenize everything, and then you realize there's a bunch of stuff that just doesn't really make sense because money is just a better medium for buying and selling legal services than a token is, right? But then the fractal is that when you realize that there's this subset of decentralized financial applications that can be represented and governed using tokens, and then that you can create token marketplaces within these, that you suddenly have this huge opportunity that opens up when you define actually what the product market fit for the use of tokens and the use of governance within that is, and the use of decentralized use of dApps. And the same thing's going to happen with NFTs. Like right now we're going, oh, you can do anything. You can represent an NFT, use an NFT to represent anything. And that's like from, artwork to royalties to, like a bunch of stuff like buildings, properties, tokenized properties, all that kind of stuff. And the same thing's going to happen. We're going to narrow down all of the things that actually make sense to be turned into an NFT as from category point of view. But then those categories will actually be incredibly deep and incredibly valuable. And our view is that NFTs are going to be the concept of real world assets, and the way that we bring the real world onto public ledgers is going to be like very much led by NFTs. NFTs all the way down, and then the other side of that is the metaverse. Like the metaverse is obviously going to be massive for NFT generation and this concept of hexaity, which I love, which is like the history of objects.
Yeah, as well. Actually, metaverse. I keep seeing that metaverse is Web3. The metaverse isn't Web3. Metaverse is an intersection of a bunch of technologies, one of which is Web3, right? And it's augmented reality, it's virtual reality, it's AI. So metaverse isn't Web3. It's those four pillars. Web3, which includes blockchain and DLTs and various other bits and pieces, artificial intelligence, virtual reality, augmented reality. And metaverse is in the middle of all those things. And I said this many years ago now, that we would see the intersection of all of these technologies, and metaverse is what you end up with.
Right. But like within the metaverse, if you want to create an in-game or cross-game marketplace for anything, like what's the best technology to build markets of things? Well, we're already proving that out within DeFi. And so like all of these things are going to converge. But for me, decentralized finance or, Web3 fintech or whatever you want to call it is a super category of all of these things that we're currently treating as like separate. Like DeFi is separate from NFTs. They're not. They're just all part of this, very large category.
They're all part of Web3. Ultimately.
They're all part of Web3, but I think that Web3, like the whole point of Web3 is ownership, and representation of ownership is to do with all links back to finance. Like why do you want to be able to represent and transfer ownership if you don't care about the value that representation of ownership
it's a little bit more than that, though, right? Like representation of ownership and value transfer is part of the whole Web3 thing, but then you've also got your own sovereignty, right? You're in control of your data as well.
Yeah.
You're in control of who can see it, who can't see it, who can you monetize it if you want to, or you have the choice not to.
Yeah, I think that is actually out of all of the Web3 dreams that are there, that's the one that I think is going to take the longest.
That's definitely at the end of the road. But ultimately, when you look at a broad scope of what Web3 hopefully will represent, then you've got all that stuff in there too. DeFi is just the easiest one, right? To go, let's get started on this, and then we'll work our way out from there. Just like Bitcoin was like, let's start with transactions and work our way out. And now we've got smart contracts and DeFi and all this other stuff. So I just like to think that people keep a broad open mind and don't try and pigeonhole the technology when it's still in the fetus stage. That's because it happens a lot, right? And this is way too good an opportunity for that to happen here.
So I'm going to go on to next question, which is by Ciprian. And I think this is going to be our last question. It's got a lot of parts.
It's a 6-piece.
Sorry?
Oh my goodness. It's got six
pieces to it. I'm gonna read all of the question, and then because I think there's quite a lot of linked concepts here. So, what happens with substates when Alice transfers 25 XRD to Bob? Will Bob's new substate be linked to both Alice's and his previous substates, or is this a single link like a chain? In this line of thought, getting the history of all transactions made by Alice, for example, would you first search for the active transactions made by her and then go backwards through all of the shutdown nodes? And I think he actually means, downstates rather than shutdown nodes, since they are all connected through the logical clock mechanism. Again, this is like confusing previous versions of consensus with current versions of consensus. How do you search for the active transactions inside a shard? Are the active transactions inside a hash map so that you can search for them faster in a tree-like structure? What is the maximum amount of data that can be contained in the ledger entry, e.g. a substate? Is there a pruning mechanism so that shards don't become too large? From what I understand, shards only operate on active transactions brought up. Those that are shut down are therefore for history. Are old transactions somehow pruned from the shard so that it can operate faster on the active ones? Again, this is sort of, We've covered this a few times, but this is a question I think that misunderstands how sharding is essentially a substate based operation rather than a address based operation, and so shards are very unlikely to get large. Any individual shard is very unlikely to get large. Based on the metric, do you decide that a transaction should go on it? How do you decide? Based on what metric do you decide that a transaction should go to a different shard? And what happens if you want to move transactions to a new shard, but you don't have enough nodes to validate it?
Okay, it might actually be easier to move from 6 to 1. Okay, so first thing, your state doesn't move, right? So you've got a piece of substate. It's some piece of state that's an up, and let's say that up state represents 10xRD, right? And that's got a particular address in shard space, state shard space, which is one slot of 2 to the power 256.
And how did it get there in the first place?
Yeah, I'm getting to that. And it never moves, right? And where it lives in that address is defined by the hash of that state. So you've got a particular piece of state that says Piers has 10xRD. Then you hash that, and that gives you a 256-bit value, which conveniently just maps directly onto our substate address space, which is also 256 bits in size, right? So the hash of that state tells everybody in the network, even if I don't have any information about any other thing that Piers has done in the entirety of his life on this network, if I'm given that piece of state, I know where it will live. And if I'm given the hash for that piece of state, I know that I can go and find it. And I can go and ask the relevant replicas, full nodes, validators in the network, can you please give me this state? Because I know that you should have this, right? It's a different conversation about why. Actually, no, this falls into the same conversation, right? So your transaction, your state, or the constituents of your transaction, which are these state pieces, they never move. So it goes into an upstate at this hash location, and then whenever anything happens with it, it's read from, or it goes in the downstate. That also happens in that hash location. So that particular slot in that state address, in that state shard space, has the entire life cycle of that piece of state that says that Piers has 10xRD. When Piers spends that 10xRD in his transaction, he will say, hey, I'm spending this 10xRD that lives at this hash in this state shard space. And so everybody knows, okay, so Piers thinks that he's got 10xRD that lives there. I know who I need to go and ask to, which is what we'll get to in a second. I know who I need to go and ask to make sure that this is valid. So they ask, they do consensus on it, and then that piece of state in the same hash location in the state shard space, then another piece of information gets added, which is basically this is now down, this has been spent. So if Piers tries to spend that again, there's a piece of state in there that says this is now in the down state, you can't spend it anymore. Here is the agreement where everybody who needed to agree that this was going into a down state agreed. And here are all the signatures for them and how much stake they had, and et cetera, right? So I can always also prove, this touches one of the things in there, given any piece of state, I can always prove that it was valid and that it was validly agreed upon without needing any other information from anywhere. So if I'm given a hash, I can go and get either the up or down or whatever else I need from that location in shard space, pull that state out, and it will have a quorum certificate with it. And the quorum certificate basically represents everybody who looked at and agreed with or disagreed, because you could store quorum certificates that disagree as well for historical reasons if you wanted to. And it will tell me who agreed, who disagreed, what the signatures were that they agreed with, who signed it, who didn't sign it, etc. I don't need anything else. Right? I can just go on that. I don't need to go and look at Piers' entire transaction history and follow a bunch of up-downs across months and months of interactions. I just need that one thing, and that will tell me if this was correctly executed and if it was agreed upon or not agreed upon. So that's really important. So given that your pieces of state, right, these bits of state always live in the same shard space, what actually moves around on the shuffling are the validators. The state stays the same, right? So if I've got a validator that's serving, I don't know, 10% of the shard space, right? And let's say that there's 10 other groups, right? So there's 10 groups. And so the entire shard space of 2 to the power 256 is chopped up equally into these 10 groups. And then I'm moving because churn, right? Security, make sure that everybody's always moving around so you don't get stale validators that can collude, et cetera. Right? So I need to move from group 1 to group 9, right? I just move. All the state, everything else stays in group 1, right? Somebody else enters group 1, I leave group 1, and I go to group 9. Somebody's left group 9 and gone somewhere else, etc., etc. It's the validators that move around, and the validators that then move into a new set to freshen that set, right? To churn the set so that you can always be sure that you'll have resilience against collusion, all this kind of stuff. The state itself always stays in the same place in terms of the address space. It's the validators that move around the address space. So is there a pruning mechanism so shards don't become large? So what actually matters, right, is in terms of my validator serving a particular set of shards in this group, is that if that group is spanning too many state shards in the shard space, that it could be terabytes of data, right? So in those instances, what you would either want to do potentially is increase the number of groups to reduce the amount of load upon all the individual validators. So you could say, okay, we've got 10, we want 20, and then the amount of storage space required for each validator is, say, a terabyte, right? Or you could look at some really historical state or ephemeral state, because you might have some instances of that as well, where it's a state that has been used within a transaction for a short period of time. You could potentially prune some of that stuff if you wanted to. Or you as a validator could say, well, I don't really want to hold everything because I haven't got the storage space, so I'll just hold the past 6 months, right? The current state in the past 6 months. Somebody else that has loads of hard drive space, they can say, well, yeah, you know what? I'll be like a historic node, right? I'll store all the state forever for any shard forever. So you can tune that a little bit as well. Also, like with pruning mechanisms too, you could also do kind of repackaging of state potentially. So instead of storing all the really kind of verbose information about a particular transaction, you could maybe trim that down, right? So do I need the Merkle hash anymore? Well, if it's really old, maybe not, right? Or do I need to store some Bloom filter that's associated with who voted and who didn't vote? Maybe not, right? So there's maybe some choices that can be made there once we start to have large repositories of state. But I mean, that's all to be decided yet. But you potentially can compress it.
Yeah, these are sort of like future-looking problems that are real optimizations of a very large system.
We're nowhere near them yet. We're nowhere near them yet. So, how do you search for the active transaction inside a shard? What are the active transactions inside a hash map? So when Piers makes this transaction to spend this 10 XRD and send it to somebody else, or maybe he's buying, some hair gel or something, Piers will actually construct the transaction, and he will put in that transaction the hash that represents that 10 XRD. So I, as a validator, if I receive that transaction, I don't need to go and find what Piers is trying to spend. He gives that information to me. He says, this is what I want to spend, and this is what I want to spend it to, right? Now I can look at that hash and I can go, okay, so this hash lives in shard group 5. I'm in shard group 2. So I'm not responsible for this, but I can just act as a relay node, right? Maybe it was just whoever Piers was last connected to, and I was that person. So I can look at that hash and I can look at the current shard group settings, right? Which validators are where, because I know that information. So I can say, well, actually, Jacob is in shard group 5, so I'll send this thing to him because he's responsible for Piers' state right now, and I know who Jacob is, and I've seen him interacting in the network on various things. I know he's live, etc., etc. I'll send it to Jacob. So we get sent to Jacob, and then Jacob gets it. He looks at the hash. He looks at the shard space that he's serving. Oh yeah, I've got that bit of shard space. I will relay this transaction to all the other validators in my set. So I'll gossip it to everybody else, and then that gets gossiped to everybody else. And in the current instance of, say, if you had a leader-based mechanism, there'd be a leader within that set somewhere, and they would pick up that transaction and include it in the proposal. So they would say, okay, I've been given this transaction relayed by Jacob. There's the hash. There's the other bits and pieces in here. I've got that state. I can process that state, do a proposal. And then everybody then votes and agrees on whether Piers can actually spend that 10 XRD or not. And if the vote is a supermajority, 67% or more, then that transaction is agreed, and the state transition of Piers spending that 10 XRD to somewhere is then processed and committed to ledger. Now in that shard, there's an up and there's also a down, and that down also has information about the validators that agreed, who it was sent to, right? Like the other hash, if P has spent all 10, or maybe if he spent 5 and got some change back, it's all then contained within that state shard. So if I want to then audit the life cycle of that piece of state, I can just look at the hash, I can go to that place, I can pick it out, and I can see, okay, this was spent fine, this was received, blah, 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 current certificates, etc., etc., etc. All those in that one place. But then at that point, that state shard is potentially available for use at some point in the long future because of shard-256 collisions.
Highly unlikely, but can happen.
Highly unlikely, but if Radix is around for a couple of million years, then maybe.
One of the like a subsection of this question here is sort of like, how do you know what the active? How do you search for the active transactions within a shard? There's an important idea here around history of transactions. That's where things like the gateway nodes come in, because what you have is you have from a user point of view, the user wants to know, well, what's all my transaction history and all that kind of stuff.
That's not even the question. So what he's actually asking is like, how are they stored on Validator, right? Which is the same way as how it would be stored on an archive or gateway node. And basically it's just a database.
Right.
So at the moment we're using Berkeley DB, which is essentially a key value store. And so as a validator in shard group 1, then I would just have a key value mapping for all of these bits of state shards. So Piers' 10xRD would have a hash, and I would have a hash as a key on that database, and then I would have the state information as the value. So it's just a database key value store.
I suppose the point I was making is it's not the node's responsibility to tell the client which like what to submit. It's the node's responsibility to then validate what has been submitted by the client as to whether or not it's valid.
Yeah. In the same way, it's like with the Bitcoin transaction, right? When you make a transaction in your Bitcoin client, your client knows what you spent, what you haven't, right? What the unspent UTXOs are. So the client constructs a transaction, sends it to the network, and then the network verifies that it's correct, right? The network doesn't figure out, okay, you want to spend 10, what's the best way for you to spend 10?
Right. And bringing it full circle, the transaction you submit is deterministically mapped based on its hashes as to where it is in the shard space. So the network knows automatically which nodes should be validating that transaction. And the nodes are then able to look up on the shard based on the hash of the transactions that have been submitted on its table.
Database. Do I have that? Yes, I do.
Is it valid? Is it up or down? Yes, it's in an up state. Is this a valid signature to send it into a down state? Yes, it is. Okay, fine. And then quorum is reached and the transaction is recorded. Cool. All right. Easy. All right, Dan. Well, it's been fantastic chatting with you as always. And thank you everyone for your great questions. I'm sorry we didn't get through as many this time. There were some really complicated ones and we got some good detail.
Yeah, we went deep into this, Simon. Cool. Bye, guys.
Thank you very much.